Welcome to 8.8's Math Moment. Today students worked with box plots in order to provide a visual representation of a data set. Okay, in a box plot, it not only shows the smallest value and the largest value, but it also shows the median of the data set, the first quartile, and the third quartile. So it gives a nice visual picture of a lot of different pieces of information in the data set. So let's take a look at example 1. It says make a box plot to represent the dot plot data. So to start my box plot, the nice thing about a box plot is that I first show my minimum, which is the smallest number in my data set, and my maximum, which is the largest number in my data set. And to do that, it's pretty simple. So I just draw a dot and a dot to show the minimum and the maximum. So far I've got 23 as my minimum, 29 is my maximum, and I've already done part of my box plot. Now I'm going to go ahead and find the median and the first and third quartile. So to do that, I'm going to write my numbers out that are represented by the dots. I don't have anything in 24, but I do have 3 25s. I have 2 26s. I have 4 27s. I have 4 28s. And then I have 129. So looking at all these different pieces of information, in the last lesson we learned how to find the median. And remember that the median is just the exact middle of a data set. So to figure that out, I'm going to cross one off the front, one off the back, one off the front, one off the back, and continue that pattern until I get the exact middle. Now when doing this strategy, it's very important to stay focused and make sure that you're crossing exactly one off the front and its same partner off the back. So I found that my median is 27. That's the exact middle of my data set. So on my range here, my line, I'm going to go ahead and draw a line here to help me remember that that's my median. And I went ahead and labeled it just to help myself remember. Now I'm going to find my first quartile, which is the middle of the lower half of data. So I'm going to cross one off the front, one off the back, follow that same strategy to find the middle of the data set. And in this case, the first quartile is 25. So again, I'm going to go ahead and label that as Q1 just to help myself remember. And then I'm going to find the third quartile, which is the middle of the upper half of data. So I cross one off the front, one off the back, one off the front, one off the back. Now this is exactly the middle of that data set, so I'm going to label it as quartile 3, and I'm going to place that amount here with a label to help me. Now that I have completely figured out all of the pieces of information, I have my minimum, I have my maximum, I have the median, the quartile 1 and quartile 3. What I do is I create a box between quartile 1 and quartile 3 with the median labeled in between to help me see that this first part is the half of the middle of the first half. The second part here, the end of the box, is the middle part of the second half of data. And then I have a line with a dot to show me how far it extends. That's the maximum number is 29, and it goes as low as 23. Now, some box plots look very even, meaning that the middle, the median is right in between the quartile 1 and quartile 3. But if it's not quite even, that doesn't mean that your student did it wrong. What that means is the the data might be heavier on one side than the other. In this case, our median was 27. I have a lot of 27s here, and then I have dots that spread out much lower. Like I have one that's all the way over here at 23, where on the other half of my data set, I just have 28s and 29s. So this box plot is not incorrect, even though it looks uneven with the median, because all that means is it's giving us that visual representation that I have data on the lower end that might extend more than the other side. So this would be a box plot and an example of how it would look. Again, showing my minimum, my maximum, quartile 1, quartile 3, and the median right in the middle. The next thing that students learned today was they learned about the interquartile range, which we refer to as IQR because of the letters in the words. All right, interquartile range is a big mouthful to be saying when we are teaching and when we're learning, so we refer to it as IQR. And the IQR is very simply put, it's just the difference between the upper quartile and the lower quartile. All right, and the only reason that we discuss it and we talk about it is because it helps describe the spread of data. Okay, and a mathematical way to think about it is interquartile range equals quartile 3, which we've already figured out, minus quartile 1. So range has always been described in math as the difference between two numbers, the range in between. Okay, and so that's where the range comes in this phrase as well. Interquartile just means in between the quartiles. So what's the difference between the different quartiles? So all you have to do here, and we're going to work with this example, is take quartile 3, which was 28, minus quartile 1, which was 25. So my interquartile range would just be the difference, which is 3. So my IQR in this example would equal 3. Now, how does that help us? It helps us know that the spread of data in this data set is not very much. I don't have a lot of numbers that are very different from the rest of my data set. They're all pretty compacted together, which you can see on the dot plot, and you can also see represented on the box plot as well. If you have any other questions about this lesson, make sure to see your math teacher.